Have you ever gazed skyward and wondered if there's life beyond our little blue planet? From the dawn of time, humans have looked to the cosmos with a sense of awe and curiosity. We've gazed at the twinkling stars, the glowing moon, and the red dot in the sky we call Mars, and wondered if we're alone in this vast universe. Our curiosity didn't stop at mere speculation. We've sent numerous missions to Mars, our celestial neighbor, with one burning question on our minds. Is there life on Mars? Not the kind of green aliens with antennas we see in science fiction, but microscopic life forms, tiny organisms that could prove we're not alone in the universe. The idea of microbial life on Mars has captivated scientists and space enthusiasts alike. It's a question that has driven space exploration, sparked heated debates, and inspired countless dreams. Today, we delve into the cosmic question, is there microbial life on Mars? Mars, the fourth planet from the Sun, has always been a subject of intrigue. Often called the Red Planet, courtesy of its rusty, iron-rich soil, Mars is a world of wonder that sparks curiosity and fuels the imagination. Just over half the size of Earth, Mars is not a large planet, but what it lacks in size it makes up for in mystery. Its surface, strewn with the largest canyon and the tallest volcano in the solar system, tells tales of a geologically active past. But what truly makes Mars a fascinating subject is its atmosphere, made up primarily of carbon dioxide with traces of nitrogen and argon. Mars's thin atmosphere allows for extreme temperature variations, ranging from -125 degrees to a balmy 20 degrees Celsius. This extreme climate, combined with a day length remarkably similar to ours, provides an eerie echo of Earth's conditions, albeit a frostier and less hospitable version. However, it's Mars' potential for water that truly piques our interest. The presence of polar ice caps made up of water and carbon dioxide, along with evidence of dried-up riverbeds and ancient lakes, suggests a wetter, possibly warmer past. This, coupled with recent findings of seasonal flows of salty water known as recurring slope lineae, adds to the tantalizing possibility of Mars once hosting conditions conducive for life. Beneath its surface, Mars further invites exploration. Recent discoveries point to a vast subsurface lake near the planet's south pole, further whetting our appetite for the Martian mystery. These underground reservoirs, shielded from the harsh surface conditions, could potentially harbor life, past or present. With such intriguing conditions, the question arises, could Mars host life? As we delve deeper into the Martian mystery, we strive to unravel the secrets this celestial neighbor holds. Each discovery brings us a step closer to understanding our place in the cosmos and the tantalizing possibility of life beyond Earth. The search for life on Mars is not new. It has captured human interest for centuries. Our foray into the cosmic neighborhood began long before the advent of modern technology. We've been casting our eyes and minds towards the Red Planet, with curiosity piqued and imaginations ignited, since the 17th century when Italian astronomer Giovanni Domenico Cassini first observed Mars through a rudimentary telescope. The Martian allure intensified in the late 19th century when Percival Lowell, an American businessman and astronomer, erroneously interpreted Italian astronomer Giovanni Schiaparelli's term canali as canals, sparking widespread speculation about an advanced Martian civilization. As our technology advanced, so did our pursuit. In the mid-20th century, our curiosity propelled us beyond the Earth's atmosphere and into the vast expanse of space. The space age marked the beginning of our active search for Martian life. Our first successful visitor, NASA's Mariner 4, flew by Mars in 1965, returning the first close-up pictures of another planet. But it was the Viking missions in the 1970s that first sought to answer the question of life on Mars directly. Viking 1 and 2 were the first spacecraft to land safely on Mars and conduct experiments explicitly designed to detect life. The results? Inconclusive, but they laid the groundwork for future exploration. The turn of the millennium saw a significant shift in our Martian life hunt. No longer were we looking for little green men or canal-building civilizations. We began to search for the simplest forms of life microbes, This shift was fueled by discoveries on Earth that life could exist in extreme conditions previously thought uninhabitable, in the deepest oceans, the driest deserts, and the coldest glaciers. Today, our rovers trundle across the Martian surface. Our orbiters circle above, and our scientists on Earth analyze every speck of data, all in search of one thing: evidence of microbial life. As our understanding grew, so did our focus shift from intelligent Martians to tiny microbes. Over the decades, space missions have provided compelling evidence pointing towards the possibility of microbial life on Mars. Let's start with the Viking missions of the 70s. They were the first to land on Mars and carry out experiments to detect biological activity. Remember the labeled release experiment? It seemed to indicate metabolic activity, but the lack of detected organic compounds led most scientists to dismiss it as a false positive. However, some researchers still argue that Viking might have found life and we just didn't realize it. Fast forward to the late 90s and we have the Mars meteorite ALH 84001 causing a sensation. This Martian rock found in Antarctica held structures that some scientists argued were fossilized bacteria-like life forms. Though highly debated, it sparked renewed interest in the search for life on Mars. In the 21st century, our rovers and orbiters have found more substantial evidence. The Mars exploration rovers, Spirit and Opportunity, found signs of past water activity. Spirit discovered silica deposits, which usually form in water, and Opportunity uncovered hematite blueberries, indicating a long-gone era of liquid water. Then the Phoenix Mars lander in 2008 discovered perchlorates in the Martian soil, chemicals that on Earth are often associated with life. Not to mention, it also confirmed the presence of water ice in the Martian subsurface. But it's the Curiosity rover that's been the star of the show. It's found organic molecules, the building blocks of life, and evidence of an ancient lake that could have supported microbial life. Curiosity has also detected methane in the Martian atmosphere, which on Earth is primarily produced by living organisms. Currently, we have the Perseverance rover and the Ingenuity helicopter exploring the Jezero crater, an ancient lakebed, looking for signs of past microbial life. Perseverance is also collecting samples to be returned to Earth by future missions for detailed analysis. And let's not forget the European Space Agency's ExoMars mission, which aims to drill beneath the Martian surface where life, if it exists, could be hiding from the harsh surface conditions. Each finding, each mission, has its share of skeptics and believers. They all have one thing in common, though. They are all looking for life, past or present, in a world beyond our own. These missions aren't just a search for microbes on a distant planet. They are a quest to understand our place in the universe. As we continue to explore Mars, we're not just looking for signs of life. We're also understanding more about the planet's history and climate and how life, if it ever existed there, might have survived. Each discovery, each piece of evidence, no matter how small or controversial, brings a surge of excitement. Each mission brings us one step closer to answering the cosmic question. The search for life on Mars is not without its challenges. Indeed, the red planet has always been a tough nut to crack for scientists. It's like attempting to solve an intricate puzzle with pieces scattered across millions of miles. Firstly, let's talk about the Martian environment. It's harsh, to say the least. The planet's thin atmosphere, intense radiation, and extreme temperatures make it a hostile place for life as we know it. The average temperature on Mars is -80 degrees Fahrenheit, and it can drop to -195 degrees at the poles in winter. It's a desolate world, with a surface scarred by billions of years of meteor impacts. The second challenge is the sheer distance between Earth and Mars. Even when the two planets are at their closest approach, Mars is still over 34 million miles away. This makes the logistics of sending probes and rovers to Mars incredibly complex and expensive. It also means that data transmission can take anywhere from 4 to 24 minutes one way, making real-time control of these probes impossible. Thirdly, there's the challenge of interpreting the data. Mars is a world full of geological and chemical surprises. Its rocks and soil contain a dizzying array of elements, some of which could be signs of past or present life, but could also be produced by non-biological processes. Distinguishing between these possibilities requires careful analysis, and often, the data raises more questions than it answers. Finally, there's the challenge of contamination. Any spacecraft we send to Mars could potentially carry earthly microbes with it. These stowaways could potentially survive the journey and set up shop on Mars, confusing our search for native Martian life. Despite these challenges, the quest for Martian life continues. Scientists are undeterred, fueled by the tantalizing possibility of discovering life beyond Earth. As we continue to explore Mars, each challenge we overcome brings us one step closer to answering the cosmic question: are we alone in the universe? Imagine the day when we finally confirm the existence of microbial life on Mars. This revelation would have far-reaching implications, altering our perception of life and its place in the universe. It's a discovery that would ripple through various fields of study, affecting everything from biology to philosophy. First and foremost, finding life on Mars would redefine our understanding of biology. It would give us a second data point in the universe where life exists, suggesting that life might be more common than we once thought. It could also offer insights into the origins of life itself, perhaps leading us to revise the theories we hold dear. But the implications don't stop at biology. If life exists on Mars, it's likely that it evolved independently from life on Earth. This would provide compelling evidence for the concept of convergent evolution, the idea that life can emerge and thrive under similar conditions, even in different parts of the universe. Moreover, finding life on Mars could have profound implications for our future in space. It could inspire a new wave of interplanetary exploration as we search for more signs of life in our solar system and beyond. It might even influence the way we approach space travel, prompting us to take extra precautions to avoid contaminating other worlds with Earth life, and vice versa. On a philosophical level, confirming life on Mars could change the way we see ourselves. It might make us feel less alone in the cosmos, or it could make us feel even smaller and more insignificant. Either way, it would force us to grapple with some big questions about our place in the universe. Finally, let's not forget the social and cultural implications. The discovery of Martian life could spark public interest in science like never before, leading to increased funding for research and education. It could also inspire a new generation of scientists, engineers, and explorers, eager to uncover the mysteries of the universe. The discovery would indeed be a game changer, not just for science, but for humanity. The search for life on Mars is a journey of discovery that pushes the boundaries of our knowledge and technology. It's an odyssey that has spanned centuries, fueled by curiosity and a profound desire to comprehend our place in the universe. Over the course of this video, we've journeyed through the history of Mars exploration, from the earliest telescopic observations to the cutting-edge robotic missions of today. We've delved into the tantalizing evidence of past and present life, from ancient riverbeds and dried-up lakes to the mysterious methane emissions that hint at possible biological activity. We've grappled with the formidable challenges of finding life on Mars, from the harsh and inhospitable Martian environment to the technological hurdles of sending life-detecting instruments across millions of miles of space. But despite these challenges, the quest continues, propelled by the tantalizing possibility of discovering extraterrestrial life. The implications of finding life on Mars are profound. It would revolutionize our understanding of biology, forcing us to rethink what we know about life's ability to adapt and survive. It could provide clues to the origins of life on Earth and perhaps by extension the potential for life elsewhere in the universe. But beyond the science, the discovery of life on Mars would have profound philosophical and cultural implications. If we're not alone in the universe, what does that say about our place in it? How would it change our perspective on ourselves, our planet, and our future? The search for life on Mars is also a testament to human curiosity and ingenuity. It's a reminder of our capacity to dream big, to rise to challenges, and to push the boundaries of the possible. It's a journey that inspires us to ask big questions, to seek answers, and to never stop learning. As we continue to explore Mars, it's important to remember that the search for life is not just about finding aliens or proving that we're not alone. It's about understanding our own planet and our place in the cosmos. It's about the pursuit of knowledge and the joy of discovery. It's about asking questions and seeking answers, about pushing the boundaries of our understanding and our capabilities. So, as we stand on the brink of a new era of Mars exploration, let's stay curious. Let's keep asking questions. Let's continue to push the boundaries of our knowledge and technology. And most importantly, let's never stop exploring. As we continue to gaze at the red planet, the question remains, are we alone in the universe?